and take out module 2, Kedah set 2. Question 1 is C. John Dalton for atom, Thomson for electron, Rutherford for proton, Neil Bohr for shell, James Chadwick for neutron. Question 2 is Form 4 Chapter 3, which is C. Which one is true for 1 mole of substance? A is wrong because remember zinc is for atom, not molecule. B also wrong because N33 is molecule, not atom. C is correct. Carbon dioxide is same number of molecule as 12 gram of carbon 12. D is wrong as well because O2 molecule, not atom. Question 3 is A. From chapter 4, where is group 18 located? I mean, like, which element is located in group 18? So helium and krypton, yes. They got helium, argon, helium, neon, argon, krypton, xenon, radon. So all this no lah. B, C, D. C actually argon, yes, but platinum is not. D actually xenon, yes, but selenium is not. Question 4 is from chapter 5. Metallic bond. Metallic bond is C. Remember, it's a bond form involving electrostatic attraction force between C of electron and positively charged metal ion. For example, Na. So Na will donate electron to become Na positive and a lot of electron. So the more of this happen, there are a lot of positively charged and a lot of electron. A lot of electron we call it electron C. So this together, these two they produce a force which we call electrostatic attraction force, which named as metallic bond. A talking about covalent bond, transfer of electron, and not covalent bond. This one is sorry, I'm trying to change a bit. This one actually ionic bond. Transfer of electron is ionic bond. Sharing of electron is covalent bond. B is talking about dative bond. Dative bond similar to covalent bond, but only come from one atom only. Remember, one side reach one side per one. Question 5 is donkey. The grid of this pyramid. Actually, these are made out by ceramic one. From 4 chapter 8. Even I think your textbook mentioned one. Made out by, remember, it's aluminum oxide. Ceramic contain of this aluminum oxide. Or you don't remember like clay or alumina silicate. Question 6 is C. From 1 chapter 4, synthetic polymer is human made. So it's C, polystyrene. All kind of polystyrene is your, remember, food packaging, the white color one. A, B, and D is your natural polymer. Come from all the plants or animals. Question 7 is graphene. Graphene actually is B. Not a feature. Not a feature means graphene actually got 6 properties. Transparent, very good conductor of electricity, very strong and hard. Impermeable. Remember, impermeable means like a lot of substance they can't go through graphene except for water. That's why they can do water filtration. Because remember, mostly the nanoparticles are very small, 10 to the power -9. except water. Water smaller than graphene. Question 8 is from 4 chapter 2. This one is about isotope one. So first one is correct. Iodine 131 is for to locate the brain tumor and thyroid gland disorder. And this one you remember the isotope function. Number 2 is wrong. This one is phosphorus 32 to measure the rate of absorption of fertilizer by plant. The third one is correct actually. Study blood circulation and detect the position of blood clots. Or normally the function you can write is normally in textbook is detect leakage in underground pipes. The fourth one is wrong as well. Fourth one is to estimate the age of fossils. This one is actually carbon 14, not cobalt 60. Cobalt 60 is for to kill the cancer cell. So the answer is 1 and 3. B. For question 8. Question 9 is for chapter 3. Now this one is limit the reactivity with whether with oxygen, whether with carbon, whether with hydrogen. So this one is with talking about hydrogen. Metal oxide with hydrogen flame, as you can see, hydrogen flame. So metal oxide which one they can use in this? Which one can use as a metal oxide with hydrogen? Now this one can remember. So you have to know the reactivity series first of all. Then you have to remember hydrogen is between zinc and iron 3. So the accepted one is from iron, tin, lead, copper, and silver oxide. This one accepted. Why? Because this one can react with hydrogen. Why? Because so that the lonely hydrogen can take away the Fe2 oxide from Fe. They can replace because remember the top one is stronger, the bottom one is weaker. So hydrogen, which is stronger, can take away the oxide from Fe. Same thing as this. Ag is weaker, so hydrogen can take away. Like for example, I can take away, like for example, like a couple. So this one boy, this one girl, I can take away. This one is boy, I can take away the girl. Example lah. Example. Who stronger can take away who. So that become H2O, then Ag become alone. But this one is cannot. Why? This one is stronger. So for example, K is stronger than H2. So H2 don't have the power to take away. So means they have no reaction. All they have no reaction. So the answer accepted is donkey. Ag2O. The other one not accepted. Question 10 is Form 4 Chapter 5. Actually B. They're talking about double covalent bond. Double covalent means got double bond. Means they share 2 for each. Nitrogen they share 3. Why? Because they have 2.5 electron arrangement. So they share 3 for each. They become triple covalent bond. Triple. O is double only. They share 2 each. Hydrogen they only share 1. Because they only have 1 electron. They share 1 to achieve stable duplet electron arrangement. Some they have single covalent bond, single, double, triple. F also single. Since 2.7 only need to share 1. So the answer is B. Double covalent bond. Double. Question 11 is actually homework chapter 6. This is actually long key. Very simple. which of the two solutions will produce neutral when they mix. So means what added what become neutral. So of course neutral is acid plus alkali. Remember, acid plus alkali becomes salt and water. The water is neutral. So which one is acid? A and B. Which one is alkali? D and E. C is neutral. So of course you won't use neutral to add into solution. You use acid or alkali. The best pair will be B and E. A and B cannot be acid and acid. You cannot be alkali and alkali. You cannot be neutral and alkali. You must be acid and alkali. Question 12 is from chapter 7. This one is okay about you remember this is a factor of catalyst. So catalyst what happen? Catalyst, remember this graph is called energy profile diagram, by the way. Energy profile diagram look like this one. So they have activation energy. This is called activation energy. Activation energy is between here to the peak of the curve. This is called activation energy. So what happens is, when they add without catalyst first, we don't have catalyst, they will have higher activation energy. If they have catalyst, they're adding catalyst, they will have lower activation energy. So the answer should be, they ask which one is curve. Explain the changes of curve 1 to curve 2. So you can say presence of catalyst. Normally this graph is showing for catalyst one. Can I? Question 13. Question 13 is Form 4 Chapter 8. So Form 4 Chapter 8 what happened? Form 4 Chapter 8. This one is talking about alloy one. So what happened to alloy is, now maybe they're not talking about alloy directly, but actually this one is talking about alloy. So for example, they use gold as an example. So maybe gold is not in your syllabus, but agak-agak if you know what is alloy compared to pure metal. Pure metal is one element only. One element only. For example, if you use iron, then all the particles iron, all the component iron. But what is alloy? Alloy, for example, steel. So steel, you have to iron add carbon, for example. So oh sorry, why? Okay, I explain this after that. I go back. So alloy is what happen? Alloy, they have two or more, the mixture of two or more elements. So what happen? Alloy become stronger. So they ask which one is which gold purity is suitable for Anmina who has hobby of extreme sport. Extreme sport meaning they have maybe they have all the kind of scratches, all the kind of hitting. That's why your goal need to be tahan, your ring to be tahan lah. So the answer is yes, 18K. Yeah. Because you have to add more other parts so that you can disturb the structure of the element. The answer is 18K. Yeah. Cannot be just holding gold not strong enough. They have to add some other material to disturb the structure, alloy, so that it become more even stronger. Okay. Then I go back to this question. As I mentioned now, this one only for catalyst one. This one just want to show whether with catalyst or without catalyst, uh, what is the factor? Now, how they disturb the lower activation energy so that it affect the rate of reaction. Now this graph mainly for catalyst one. Energy profile diagram, whether you see is talking about catalyst one. First one you have without catalyst, higher activation energy. Second, with activation energy. That's why you have lower activation energy. Yeah, it must be B. Mainly talking about catalyst one. Cannot be other things. Cannot be other factor. Question 14. A. This one is Form 1 Chapter 1. Now, this one is talking about whether undergo oxidation or reduction. So if you still remember what happened, oxidation is, remember this O1. So what happened? They will gain oxidation. Oxidation is reducing agent where they have reducing agent, oxidizing agent for reduction. So what happened is they will gain oxygen, lose hydrogen, increase in oxidation number, lose electron. This one terbalik. Same thing O1, but just a sign terbalik. So what happened is H2S is a reducing agent. Why? Because they undergo oxidation. Actually, H plus is not involved because H plus still H plus. The one that involved is S. S is actually S2 minus. S2 minus, as you can see, even though you don't know also, you can see the formula. H2S. So H plus and S2 minus. So S2 minus is -2 oxidation number. So undergo oxidation become 0. This is oxidation. Increase in oxidation number. This is oxidation. About the other one, bromine is undergo reduction. Why? Bromine actually got Br2 is actually 0. No charge means 0. Oxidation number. What happened? Decrease in oxidation number become Br minus here. So -1. 0 decrease to -1. So they call it reduction. So talking about A because hydrogen sulfide undergo oxidation by losing hydrogen. Yes, losing hydrogen is talking about oxidation. B is not. B is reduction by gaining hydrogen. As you can see also, you either can look oxidation or you can either look for oxidation number or you can look for whether they gain or lose hydrogen. For instance, this one they lose hydrogen, that's why oxidation. This one they gain hydrogen, that's why they undergo reduction, as you can see here. But first of all, you notice same as C, same as D. Always oxidation talking about reducing agent. This one is reducing agent. The reducing agent undergo oxidation, oxidizing agent undergo reduction. Question 15 is Form 1 Chapter 2. Now this one, remember, saturated is single bond, unsaturated hydrocarbon is double bond. So unsaturated hydrocarbon, remember, unsaturated is between double bond or triple bond sometimes. But normally you learn double bond only in our syllabus. Yes, we learn about alkyne also the triple bond, but not so much coming out. And hydrocarbon is H and C only. If it's non-hydrocarbon, then only you got O, all that. The other element like O, N. This one H and C. So that's why C is not accepted. C is carboxylic acid. They want only D also because, as I mentioned, you cannot be chlorine and other things. Cannot. Hydrocarbon only can have element of hydrogen and carbon. So between A or D A single bond. So wrong Unsaturated must be have double bond. Donkey. Question 16 is from what chapter 3. This is heat of displacement actually, where zinc displace tin. So what happens is, if you see heat released, why? Because it has negative sign. So heat release means exothermic reaction. So donkey lah. Now they ask what is the definition of heat of the reaction. This is heat of displacement. Displacement you have to mention this one. Heat released when 1 mole of tin 2 is displaced from a solution of tin 2 chloride by zinc. Something else. not B, not C. Heat or displacement, you have to mention like this. This is the definition. Not A also. You have to say is displaced by somebody or with from what solution. Question 70 is for chapter 8. This one is also talking about alloy, where stainless steel. Remember, stainless steel is one for alloy. They made out by four things. Component, the first main component is iron, followed by got carbon, chromium, and nickel. So chromium will make it shinier. But actually, this one they just want you to count actually. Very simple one. This one they just want you to count only. Mass of iron required. You just they already total given mass is 65. So you just percentage already given here. So you just 73 over 100% times 65, then you can get how many gram you need. How many gram of iron you need, how many mass. Question 18 is Form 5 chapter 4. What is this one is made up by material P, and this one is talking about all the polymer out there. The answer is C, yes, nylon. Yes. So nylon, not polystyrene. Polystyrene is for the food packaging one. Nylon is all the bowls, all that, mostly the ceramic made one. D is talking about the backlight. Backlight is also not this one. Backlight is for the all the button, all that. Clothes button. C nylon. Nylon can be made out of all the clothes, including umbrella. 19 is B. From chapter 6. At hydrochloric acid is acid, sodium hydroxide is alkali. The ionic equation is actually B. Remember why? Because ionic equation, you need to write the one that involve. So what happened? The one that actually change the oxidation number basically, or involve the reaction. So what happened? H plus become H plus and OH minus become H2O. Mainly talking about neutralization. But as then A plus still Na plus. But mainly because neutralization. So we don't really care about the NaCl. We want to know acid plus alkali is neutralization. Become neutral. Water. 20 is Form 5 chapter 4. So it's B. This one is talking about rubber between unvulcanized rubber and vulcanized rubber. Remember, vulcanized rubber, how to become vulcanized rubber? You have to dip the rubber strip into the disulfur dichloride and what thing? And what thing? This one, the rubber is methyl benzene. You can look back, you can see one. Then it become vulcanized rubber. You have to dip inside one. This one is normally school lab experiment. Or if normally industrial, they just heat with sulfur directly. This one is deep into disulfur dichloride and methyl benzene. Question 21 is forward chapter 3 is A. This one is your standard representation. Sometimes maybe it's subjective, they ask you to draw, they know how to draw. You just know on top is nucleon number, on bottom is proton number. And nucleon number, how to get? Nucleon number is equals to number of neutron plus number of proton. Question 22 is for chapter 4. This is group 1. Group 1, you know group 1 basically displayed by one valence electron. Very simple. 2 and 3 is correct. One valence, remember valence electron is the outermost, the electron that fill in outermost shell. So 2 and 3. First one is group 13, fourth one same. So C. Question 33 is Polymer chapter 5. This one is talking about now this one is actually B, the answer. What is the problem? The problem is glucose. So glucose C6H12O6. Now if you see like this, normally it's covalent bond. So covalent bond it cannot conduct electricity at all. So confirm it's either B or donkey. But is it B or donkey? Will be soluble or insoluble in water. Now, this covalent bond, this glucose, actually contain of hydrogen bond. You have to be careful. You have to the content of hydrogen bond. So what happens is hydrogen bond between HF, HO, and HN. So hydrogen bond makes it able to dissolve in water. You have to remember this. So covalent bond normally insoluble in water, cannot conduct electricity, but since this content of hydrogen bond, so hydrogen bond made it able to soluble in water. So the answer is actually B. Sometimes you see alcohol the same, able to dissolve in water. Because we got H and O. Either you can see H and O, H2O, you can see HF or NH3. This one able to dissolve in water. Question 24 is B. This on Form 1 chapter 1. Oxidation. Now, you have to know this one is undergo oxidation. So now, if you have to remember, you got 4 oxidizing agents you have to know. So which are the 4? So you have to know potassium, manganate, acidified potassium manganate 7, and also acidified potassium dichromate 6, and bromine water, chlorine water. You have to know this. Oxidizing agent means undergo reduction. You have to know how to convert. But simple. Fe2 plus to Fe3 plus is oxidation because they lose electron. So how they convert? What substance can you use to convert? Oxidation agent. Oxidation. You have to use oxidizing agent. This to convert Fe2 plus to Fe3 plus. So these 4 things you have to remember. If you have oxygen, you need you need another one. You need reaction. Means you need oxidation agent to oxidize this. What if it's a what if we're talking about Fe3 plus to Fe2 plus? What do you need? You actually need this one. Talking about actually need zinc. You actually need this reducing agent, which is oxidation. So oxidation, under oxidation. So reducing agent got 3. Got 3. So is zinc, magnesium, or Ki, potassium iodide. These 3. Why is it at Zn and Mg? Because Zn can they actually Zn and Mg they undergo displacement. If you remember, see what is displacement? Because Zn can donate electron becomes Zn2 plus. Same thing for Mg. Ki where the I minus what happen? I minus will become I2. Donate electron. This is the value. If Fe2 plus become Fe, then you use either Zn or Mg normally. This is the part. This is part you know. But if it's Fe2 plus to Fe3 plus, then you know is they're using oxidation. So the only possible is B, bromine water. Zinc powder, this is the this zinc powder, when you use Fe3 plus to Fe2 plus, then use zinc powder. And potassium iodide. Yeah, as I mentioned. Question 25 is for chapter 2. This one remember, just simple. When the temperature become constant means these are the either melting point or boiling point or that. In this case is cooling curve. So cooling curve is actually freezing. We learn about two melting point and freezing point for the graph. This is freezing from temperature decreases from liquid to solid. So freezing point means there got two states, which is liquid and solid. And this is heat release. Why? Because let's say the water release the heat out, so they become ice, for example. Or the heat absorbed the body. Heat absorb means like ice absorb the heat, then become water. So this heat release, T1 to T2 is liquid and solid. This one actually is orderly manner. Solid tightly packed together one. They arrange nicely one. Heat release correct. Then forces of attraction between the particles are weaker. Gas is weaker one. When it becomes solid, it becomes very strong. Question 26 is Form 4 Chapter 7. This is actually A. Magnesium 3. How to increase the rate of reaction? So you can use magnesium powder, yes. Magnesium powder, why? You know the factor, the smaller the size, the higher the larger the total surface area exposed, the higher rate of reaction. D is wrong lah. The 4 chapter 6, 4 chapter 7, I never mentioned about volume. The C is temperature, you have to increase. Concentration, same, you have to increase. Question 27 is Form 1 Chapter 2. Remember this process, all you have to remember. Ethanol. If you see this, you see this acidified K-amino4 undergo oxidation. Because this is quite similar to Form 1 Chapter 1. Acidified K-amino4 undergo oxidation. So oxidation means CH3COH. Remember, oxidation means become carboxylic acid one. Because this one got one O, undergo oxidation means got two O now. CH3COOH. Why is it CH3COOH? Why you got two C? Because here got two C. So here also got two C. Then the other way is dehydration. So dehydration what happen? The answer is A. So dehydration means hot porcelain chips. That's why dehydration. You remember hot porcelain chips, the heat. Undergo dehydration minus of water become ethene, C2H4. So only got C2 one, everything. Only got two C one. So actually it's A lah. So it become carboxylic acid become alkene. This one wrong because you got 3C already. If you notice. This also wrong because alcohol become alkene, not alkane. Okay. Then question 28 is Form 1 Chapter 5. Fats and oils. Remember how to make fats. Fats under means glycerol plus fatty acids. And you remember glycerol similar to alcohol one. If you notice, fatty acid similar to carboxylic acid. This one quite linked to a little bit linked to Form 5 Chapter 2. Then it become ester. Fat equals to ester actually. Yeah. So 1 is correct. Second one is wrong. You have to know the difference between fats and oils. So fats actually come from animal. But oil not really. Oil come from plants. You have to know the difference. Third one is actually solid. Fat solid, correct. Oil liquid, correct. Why? Fats actually mostly contain saturated fats one. So they're mostly single bond. Oil mostly contain of double bond. Fourth one is wrong. Fourth one wrong, why? Unsaturated fat converted to saturated fat. This one similar to alkene to alkane one. Of course, this one undergo hydrogenation. Adding hydrogen one, they say C2H4 becomes C2H6. Not oxidation. So the answer is B. Question 29 is from chapter 3. It's just a calculation. 3 atoms of element Y equals to 4 carbon atom. So 3Y equals to 4C. C equals to 12 given already. So you can just find Y lah. What is the relative atomic mass of Y? You can just calculate and find out. Question 30 is from chapter 5. This one, when they see the hair is wet or you want to split the pages, this one related to two things. Only one thing. It's related to hydrogen bond. Because wet hair contain water. Water is hydrogen bond. Contain hydrogen bond. Or you want to use your saliva to flip the pages, same thing. Saliva also contain water. Question 31 is from chapter 6. This one is monoprotic acid now. Monoprotic acid. So basically, they are only produce one H plus at the time, and substance X to become salt and water. Now, the moment you see water means neutral. So what happens is acid plus what? Plus alkali. That's why it become neutral and a salt coming out. So this one is H plus and OH minus. What put the best for substance X and substance Y? So substance X is alkali. You must use alkali. X alkali. Yes, alkali only possible is. I mean, B is possible, but B contained as base because all alkali are bases. So B slightly possible, not A and C lah. But donkey is always correct one. Why? Because B takkan I suddenly become, it's correct. Copper 2 chloride might be correct. The problem is we mostly want to choose alkali. Neutralization, acid and alkali. Alkali got two choices. Two to three choices. Mostly is sodium hydroxide and potassium hydroxide. Maybe ammonia, because ammonia is weak acid, weak alkali, so we normally don't choose. Mainly it's donkey. Because B is copper 2 oxide actually is insoluble. So we normally don't use insoluble base. Normally you just add alkali. Becomes sodium chloride. Yes. This is the equation. Question 32 is from chapter 2. This one is really not clear. This one basically you just put inside everything. One by one value put inside there, you can see lah. You can see the B1 is actually equal one. Left and right equal of oxygen, correct one. All other not balanced one. Question 33 is from 4 chapter 3. This one is just talking about the equation. What information you can get? So what statement is correct? A is wrong lah, because 1 mole 2 only to 1 takkan to 2 mg to 2 mole of oxygen again. Because you cannot atom, always like molecule. Doesn't matter. O2, not 2O. This one is O2. So O2 is molecule. B is not, B is 2 times 24 is become 48, because they say already. So what happened? 1 mole oxygen, so it must be 2 mole of magnesium. 2 mole of magnesium means 2 times 24 becomes 48 gram. C, C is also wrong because this one actually is 2 mg ratio to 1 oxygen molecule. So this one is 6.02 10 to the power 23. This one actually 1.204 lah. You just times 2 lah. Donkey is correct one. 2 to 1. So 1 to 0.5 is correct. Question 34 is 4.7. Rate of reaction increases. Very easy lah. Rate of reaction increases when the concentration, you have to mention, they talk about concentration, they want a specific one. How concentration affected? So remember, what do you write for concentration? Concentration factor, you write this sentence one. If you remember, total number of reacting particles, let's say sometimes is zinc atom and hydrogen ion. Total number of zinc per unit. Normally this one is not zinc. This one is hydrogen ion, let's say. So total number of hydrogen ion per unit volume increases. Normally it's this. Per unit volume, always one. Always this one. If talking about B kinetic energy is temperature one, not concentration factor. D total surface area talking about size. A is too general. And can be anything, can be any factor. Question 35. This one is heat of combustion. Again, it shows negative. So you only know heat release, obviously. Temperature increases, become hot. Heat of combustion, yes, correct. Is negative 1400 kilojoule per mole. Donkey is wrong. Why? Energy, they already draw for you. See, energy reactant. You have to know this one reactant, some product lah. Reactant is higher than product, or product is lower than reactant. Then question 36 is for much 4, which is A. They're talking about polymer X made up by many repeating units. Many repeating units is called monomer. Polymer made up by many monomers. So which of the following is polymer X? So actually the answer is actually okay, I think the answer is okay. B, now B amino acid is polymer X. I'm talking about polymer. So this one protein is polymer, amino acid is monomer. Natural rubber, this one is actually also polymer. Isoprene, all that 2-methyl big 1,3-diene. One of polymer. This one is the I bracket one is monomer. This one is polymer. Polyvinyl chloride also polymer. So vinyl chloride all that lah. Chloroethane. This is monomer. This is polymer. So starch actually is a monomer. I mean, no, starch is actually how to say, no, sorry. Actually, yeah, look back. And the answer is maybe I made some mistake of it. Uh, 36A. Correct. So what happened is actually all given are polymer actually. I think I wrote. Answer is correct. Just I explain only. Yeah. This one actually talking about, sorry, I just like about places lah. This one actually monomer. Which polymer? So polymer is actually this one lah. Starch is the one lah. So basically many glucose become starch. Many amino acid become protein. Many isoprene become polyisoprene means natural rubber. Many vinyl chloride become polyvinyl chloride. Just like this. This is actually also the polymer lah. So glucose is for starch one. Question 36 is actually from chapter 4. This one you just have to know they're talking about decreasing proton number. So you have to know the charge lah. So this one talking about period 3, right? So period 3, what happened? This one is formula is Y2O. O is always O2 minus one. So if it's O2 minus, then for this is Y plus lo. Cross remember always cross Y plus, this one you get X2 plus. This one you get W3 plus. So that's why is proton number is in 11, 12, 13. You have to know this one. They confirm in period 3. So decreasing proton number means decreasing biggest to smallest from W, X, Y. Donkey. Question 38 is from chapter 1. This one is uh 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 uh, uh true on the table above table. So just have to arrange. Always arrange the most negative one to most positive one. I mean it's also negative, but less negative. And more positive one always add anode one. So anode is anode to cathode. So anode to cathode is always uh donate electron. Anode always donate electron to cathode. So what happen? Anode donate electron, cathode receive. So which one oxidation? Oxidation is anode. Cathode is reduction. So reduction for nickel electrode. B actually correct. C Ni2 plus is the one undergo. It's the one that undergo reduction. Means this one is reducing agent. I mean, not reducing agent. This one is undergo reduction. So it's oxidizing agent. Sorry. The value. D one is Fe reducing agent. Undergo oxidation. This one is reducing agent. Question 39 is from chapter 6. Adding into this bubble into distilled water, litmus paper become red color. So gas X is what? Actually it's B. Because the sulfur dioxide, if you look back at the testing of gas, they use normally got two acidic gas, sulfur dioxide and nitrogen dioxide. But nitrogen dioxide is not here. So nitrogen dioxide is also this. But other than that, sulfur dioxide also they are acidic. So because acidified, when you put acidified chemical for, they will decolorize. So this one actually acidic one. Ammonia is alkaline one. C and D is neutral. Last question is for paper 1, for 5 chapter 3 1. This one is just calculation. Remember, they given delta H. So they want volume how much? So volume it can form number of mole equals to mv 1000 or 1000. Before that you have to m. M will actually have lah, but number of mole do you have? No. So you have to find number of mole through this formula. Because they also given Q here. This is Q. This is delta H. So you can find out. One is 12 kilo, one is 1.12 kilo. You get 0.1 mole. And ratio is the same thing, 3 to 3. Solution. So MV over 1000, you can find V equals to 100. So do you have any question? No. Pause a bit. If not, then we move on to area. To paper 2 already. Module 2. Okay, sorry. 23. Wait, and 23. Yeah, B. Supposed to be B. Because hydrogen bond, covalent bond, hydrogen bond. Actually, covalent bond not insoluble, but the problem is got hydrogen bond. Mid is soluble. Okay. The other question now. Okay. Okay. Then you can take out my module 2. I mean, not take out. You can turn out to this paper 2. Yeah, you can look at question 1. Yes, for what chapter 2. So uh question 1. So what happened is this one, you remember, this one is just heating of naphthalene. No, we are boiling pula. One is actually melting. Sorry. One actually melting. So what happened is solid to liquid, melting point, melting is solid to liquid. So type of particle, now type of particle always three things. Type of particle you can write either atom, molecule, or ion. So naphthalene is, the formula actually for naphthalene is C10H at C10H is totally molecule, yes. If you're talking about physical state, then you talk about solid, liquid, or gas. Why temperature remain unchanged? Because we can say heat absorbed. Heat absorbed to do what? To overcome the forces of attraction between the particles. Now you tell me. Equal to surrounding temperature. Actually, both accepted actually. Yeah, equals to surrounding temperature, that one also can. Actually, this one also can. Heat absorbed to overcome the force of attraction between the particles. Or you can start out, they want to say equals to the surrounding temperature. The force to overcome the force of attraction between the particles is equals to the surrounding temperature. Can also. Yeah. Or you can say the forces also to become to overcome the force of attraction. Mainly, the key point is this one. The key point is this. Okay. C state the time when all the negatively solid have turned to liquid. All. So when the moment turn the moment they stop becoming constant. So actually it's T3. T3 second. State observation when naturally heated directly. So when they say heated directly, so naturally solid actually become, you can see it become gas one, directly. It won't slowly melt one. Because we heat very strongly, directly heat, then the temperature suddenly go very high. So cannot tahan one. It's straight away you evaporate one. Okay. Uh, Question 2. You can say write out the meaning of alloy first. If you remember, 2044, chapter 8. This one actually iron and carbon. This one actually steel. If it's stainless steel, it's actually iron, carbon, nickel, and chromium. This one actually is ethene, monomer one. And now the alloy meaning first. Remember, alloy is mixture of two or more elements, which means pure metal is actually one element. So alloy is two, can be three, can be four, mixed together. But the main element is a metal. You have to listen this one. Okay. B, state the name. Okay, I already said out. It's steel. B2, hardness. So hardness compared to copper metal. Do you have to ask alloy compared to pure metal? Always have to ask one. Hardness, just alloy is of course is harder, you can say. Yep, copper only alone is weaker. When they add carbon to disturb them, the structure becomes stronger because structure is disrupted. So when you apply the force, it won't easily slide over each other. This is the explanation in case they ask. C1, name the monomer Y. Monomer Y actually is, I told you that is ethene. If because you got two carbon, double bond. E and E. Polymer. Now, polymer, remember how to draw? This one is monomer. If it's monomer become polymer, double bond you take out become single bond. Then you have to draw square bracket, and you still remember this? Just square bracket and same thing. All the let's say they come out propene, they come out polyvinyl chloride, same thing. Around the same only. You can look back the structure. Then think you finish. Okay. For question 3. Standard representation. So I talk about this one. Standard representation of atom Z, where this one is showing proton, just symbol, some proton, symbol of elements, one proton, this one nucleon. Number 3 showing is proton number. Yes. And actually this one is group 1. Based on the electron arrangement is 2.1. Group 1 what happen? If for ion names, they donate one valence electron out to become Z, it becomes Z plus. Then C, the talk about Z react with oxygen. Now, be careful. Z react with oxygen. So what happen? Z with oxygen, O2, to form oxide of Z. So Z actually is, sorry. I think I read wrongly already. And not wrongly. Actually, correct. So Z actually Z plus. O actually O2 minus when you ion oxide. So what happen is Z plus O2 become Z2O. Why? Z2O, sorry, not Zn2O. Because Z plus cross become Z2 lah. O2 minus become O1 1O lah. Then the balance balance means O got 2 here here got 1 so times 2 So times 2 means after that here got 4Z so times 4 here. BC2 just calculate Calculate the mass of oxide of Z form. Now just do the number of mole, all that. They given 0.05 mole of Z already. So very simple. 0. Is info already. Straight away you can do ratio. So 4 mole produce 2 mole of Z2O. They want this mass how much? So 0.05 means divided by 2 means 0.025 mole. Or if you don't want to write, if you scared the exam you don't remember, you write the sentence you can write Z dot Z and Z2 also can. But maybe just find slightly safer I say. Then you calculate. After that, you get this info already important. You just have times. Remember, number of mole is mass over molar mass. So the bulk mass means equals to number of mole times molar mass. 2 times 7 plus 16. Is this 7? Ah, yeah. Here that's 7. Given already 0.05 mole. Set. Maybe sometimes they give info like, oh, uh, 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 this one, how much? But they still give 0.05 mole. Then you can just use ratio to combine. This one is from equation 4z to 2z that all. Then this one is the given value. Sometimes you have to calculate lah. But this one they very kind, they given you number of moles straight away. So if you can straight away compare. Okay. Question 4. This is homework chapter 4. Because look at this table, you know, right? So what happen is remember group is vertically one. All the group vertically. Group 1, group 14, group 15, 17, group 18, period 1, 2, 3. So based on this, they ask what? The state elements that can combine to form ionic bonds, ionic compounds. Which one? Ionic compound is remember, ionic compound is metal plus non-metal. Covalent bond is non-metal plus non-metal. So this one is metal plus non-metal, where valence electron for metal is 1, 2, 3, non-metal is 4, 5, 6, 7. So except for hydrogen, hydrogen case for you actually cannot consider as metal. Special case. This one consider non-metal. Not you lah. So the only possible metal is here as well. Why? Why only the only metal? So non-metal got 1, 2, 3, 4. But actually why won't react with you lah? Doesn't seem right. So why can react with all the non-metal with V with W with X also can. So the answer can be, yeah. And exam you just write one enough lah. This one is the suggestion. Whether you write this or this or this also correct. I can be 3 answer, this 3 answer accepted. But don't write 3 lah, exam. Just write 1. B. They say element V and element W, we have to produce Z. This one considered as covalent bond. Why? Non-metal plus non-metal. 4 and 6. So what is the formula? Remember how to see? 2.4, what is they did share 4 electron. W because 0.8 is stable. So this one is share 4, this one is share 2. So the cross become 2 and 4. Cross to get formula 1. 2 and 4 is not simplified. Simplified, you have to divide by 2. Become 1 and 2. So basically the formula is VW2. And some they like to always ask, they won't give the proper, normally they don't give a proper symbol one. They like to give like all the V, W, X, all that to represent the actual symbol. But this one is not an actual symbol. Covalent bond, side of bond. Now, C, fire extinguisher. Figure 4.2 shows a fire extinguisher that uses compound Z as the main ingredient in the production of fire extinguisher. This fire extinguisher extinguish fires involving electrical appliances, gas, and steam. Now, uh, uh, then they ask you, explain why compound Z is suitable for extinguishing fires involving electrical appliances, gas, and steam. If you notice here, what they do, carbon dioxide. Now, why is it safer? Because carbon dioxide is a covalent compound. So covalent compound, what happen? They are not soluble in water. These are the few physical properties. Not soluble in water, cannot conduct electricity, low melting point, boiling point. But they're talking about electrical appliances. So cannot conduct electricity is a key here. Why? Because covalent compound, you remember one thing, ionic compound, they have charges, free moving ion. But covalent compound, do they have? No. So don't have any free moving ion. So that's why they are neutral molecules. Except neutral molecules, no free moving ion form. No free moving ion, that's why they won't conduct electricity though. It's dangerous when they conduct electricity, what man? They it's dangerous a bit lah. Compared to this. Now they ask second question, they ask tricky. Can water replace compound Z as the main ingredient in the fire extinguisher in figure 4.2? Give your reason. No. Why no? Actually, conduct water can simple conduct electricity. Very simple. You can imagine you pour water into the electrical appliances. What happen? Definitely, you get shocked. Electric shock. Okay. Question 5 is actually Form 5, Chapter 1. Now, this one, is remember one of the experiments also they did for this is impure import sometimes is copper, sometimes is silver. So impure silver, then this one is pure silver. Then M nitrate solution. So what happened? You have to remember this impure silver, they always put the anode one. Actually, this one it has battery one. This one actually undergo electrolysis process. Electrolysis has battery one. So has battery one, you have to draw one. So what happens is, if it's electrolysis, anode always at positive, cathode always as negative. So impure silver and anode, why? Because they want the silver to be cleaner. They have to take out the dirty things. Then after that, C will become pure silver. This one always, impure one always at anode one. Suitable electrolyte you can use. Since you use impure silver, so you use silver nitrate. If found with copper, then you use copper 2 nitrate. B 只是 ask you to draw this, the battery. You need to show the longer one. Longer one is positive, shorter one is negative. C is just calculate the number of mole of silver that has been extracted from the impure silver. So this is very simple. Yeah. So what happened? Have been extracted. So first of all, you see, initial mass 25.3 gram. After 30 minutes, the pure silver it increases to 36.1 gram. So how many of this extracted? Of course, you have to use minus. How many this one and not sacrifice to give this one? How many? You just minus in final minus initial. Very simple. Final minus initial. Then number of mole, they all number of mole. Number of mole just mass over molar mass. Molar mass is given 108 for silver. Then see donkey just write the equation. Anode what happen? Anode always undergo oxidation. So they donate electron. Ag donate electron become Ag plus. Cathode terbalik. Cathode will receive from others, receive from anode. So Ag plus with plus E minus become Ag. Just in case you still don't remember, positive charge So positive what happen? Positive charge. That's why the electron is negative So they attract electron. Which is right here. This one also attract electron. So they try electron like you right here. Become Ag. Now E a bit harder, I would say. E a bit harder. Why? The question is like this. So what happen? Diprotic acid. So the way you see diprotic acid, what happen? Produce 2H plus. If it's monoprotic acid, they produce 1H plus. For instance, 1H plus like what? For many hydrochloric acid, nitric acid, all that. Diprotic only normally we learn only one. I mean, you got others, but normally mainly we learn sulfuric acid. So the moment you see all the possible is sulfuric acid. So sulfuric acid, what they contain? They contain of. Now, sulfuric acid also they contain of H plus and SO2 minus one. At the same time, normally this electrolysis inside also contain water one. So what happen contain a water got H plus and OH minus. So that's why OH minus OH minus this one anode, right? OH minus, they say colorless gas is released. So colorless gas is released actually we choose between SO2 minus and OH minus we don't choose any SO2 minus one. We just choose OH minus. So because it's more negative actually, by the way. So for OH minus, this equation actually you have to remember quite important. So 4H minus become 2H2O plus O2 and 4E. So what I guess for this actually the color is oxygen. Cathode only got H plus So 2H plus receive electron, what happen? Become hydrogen gas. Colorless gas we're talking about is hydrogen gas. What about monoprotic M? Now, monoprotic M, SPM, greenish yellow. Remember this one? What's the possibility? Greenish yellow is actually one of the color in group 17 gas. Remember, group 17 fluorine is pure yellow. Then bromine is actually reddish brown, iodine actually purplish black. Then this one is chlorine. Now, that's why you got H. The acid actually is mono is HCl. So 2Cl minus anode. So 2Cl minus become Cl2. That's why greenish yellow gas is produced. Plus 2E. H plus is still the same hydrogen gas produced. Name the gas very simple. The gas is sulfuric acid and hydrochloric acid for M. Just in case if they ask you all the equation, you have to know how to choose all that. Basically, this one meaning this one may be more concentrated. That's why they choose this gas coming up. Cl2. Now, question 6 is actually from 5 chapter 3. Heat of displacement, meaning you have to know heat change when 1 mole of metal. Now, if they say based on this experiment, then you write all the silver, all the copper, silver, all that silver nitrate. Silver is being this 1 mole of silver is displaced from silver nitrate by copper. But in general, you can just heat change in if it's based on experiment, you have to write heat release because we find negative. Heat change from 1 mole of metal is displaced from its source solution by a more electropositive metal. Displacement. Now, what they put this one actually they put copper and silver nitrate. So what happen? Copper and silver nitrate become copper 2 nitrate because copper actually is stronger than silver one. So what happen? The copper will take away the nitrate from silver. So become copper 2 nitrate, silver become alone. Now, they got 3 observations you can write one. So B the ask if in case they ask 3 observation so or you don't remember so you can I have 3 suggestions here. Why copper originally what color? What color? Brown. So Ag nitrate is originally colorless solution. So after that copper you take away nitrate from silver become copper 2 nitrate. Remember copper 2 nitrate means copper 2 ion. Copper 2 ion normally got blue solution. Then silver what color alone? Gray solid. So basically got 3 things, right? One is gray solid is deposited. 2 is colorless solution turns blue. 3 is because it's negative heat release exothermic temperature increases. So you can say thermometer reading increases also can. Okay. C just ionic equation. So ionic equation is Cu becomes Cu2 plus. Because Cu becomes Cu2 plus. This is full ionic equation. So what happen is, you have to know, this is half equation. Two half equation become iron equation. So silver ion becomes silver. So silver ion become, you know how to see, So can you see away right out? Cannot. You need times 2 for silver because electron only got 1. Become 2, then become 2 Ag, 2 silver. Then you cut off the electron, no need to write. This is the result. Donkey calculation, number of mole. Now, number of mole, they already given on top. So the given is, here the given is V. Here is molarity. So you can use number of mole equals to MV over 1000. Then question now V2 they want to find heat release. Heat release is Q. So do they have, normally you, because if you know it's Q equals M theta. But here do we have M? Yes, M is 100 mass of water. But do you have C? Yes, 2.4.2. Do you have theta? No. So they didn't give any theta, but they give delta H. So you cannot use the MC theta. You have to use delta H equals to Q per mole. Because you have already got mole, then you have delta H here. So you just use mole is 0.02 times delta H is 105 kilo. Kilo, 1 kilo equals 1000. Then the third one is asking you for temperature, change in temperature, then one is talking about theta. Now, then finally you got Q already. That's why you can use Q equals M theta to find theta. Got Q just now 2100, M is 100 cm3 above. Then temperature change is to use theta equals to Q over MC. 1 kilo, this one 105 kilo. So kilojoule. So 105 times 1000. 1 kilo equals 1000. Now you have to, sometimes you have to remember, you have to be careful. They give 105 kilojoule. So remember, uh, 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 kilo is 1 kilo equals 1000. So you want to convert to joule, then normally Q, right? Joule, so that's why you have to change to joule one. Because for question 3, you see, they are 105 data. If not, your answer will be 0.005 degree Celsius, which doesn't make sense. Now, E might be a bit a tricky question. No concern, no concern, no concern. I mean, like, uh, normally when they calculate the delta H, right? Maybe this question is about it. Normally, you will calculate delta H equals Q per mole. First step, calculate Q. Second step, calculate mole. Third step, calculate delta H. Let's say normally when you do it, so, so divide by 1000, right? You get 105 kilo joule per mole. You do the next step. So what happened? Because 1 kilo, okay, 1 kilogram equals 1000 gram. Means 1 kilo equals 1000. 1K, 1K is 1000. That's why they want I times 1000 to make it to joule instead of kilojoule. Instead of 2.1 kilojoule, I got 2100 kilo. 2100 joule. It's important because for third one, you want to find the temperature change. If not, it will affect your answer. Basically, conclusion is 1 kilo equals 5000. 1K ma, never 1K. Normally you see like 2K, people earn 2K, 3K, means 3000. Now, E, now, it's difficult for this. So what happened is, uh, they ask at the beginning what they use. At the beginning, they use 100 cm cube, 0.2 mole dm cube. So what happened now is, instead they use 100 cm cube, 0.4 mole dm cube. So 0.4 means the times 2 are double. If it's double, temperature also become double. So at the beginning, you calculate is 5 degrees Celsius. So now become 10 degrees Celsius. You can either say temperature change is double, because the more concentrated, the higher change, temperature will change. Maybe you ask me why? Why? Because mole equals to, let's say this is delta H. So what happened? Okay, for example, if theta increase, what happened? I mean, if it concentrated equal, what happened? Let's say this one, mv over 1000. If the molarity increase, number of mole increase. If number of mole increase, what happened? Number of mole increase. Let's say this one increase, number of mole increase. Q also increase. If Q increase, data also increase. So this part, you can either say, you can either predict, they want to change the temperature, predict the temperature change. You can either say straight away, you say 10 degrees Celsius, or you can say temperature is double. Why? Because you can say concentration double here. Number of silver ion per unit volume is double. Heat release is double. This is explanation. So we get 3 marks. Concentration, quite a little bit similar to explanation for the rate of reaction. So number of silver ion per unit volume double, heat release double. Each one usually talking about number of mole. Okay. Question 7 is Form 4 Chapter 7. So as I told earlier, so earlier in class, Form 4 Chapter 7 got 4 experiment around lah. So you got acid plus metal carbonate, the composition of hydrogen peroxide, and also sodium trisulfate react with acid. So this one is normally is quite a popular question where metal carbonate react with acid. So they produce zinc chloride, H2O, and carbon dioxide. So actually what they collected the gas is carbon dioxide. After 3 minutes, they collect this amount of gas for set 1, for set 2. If you notice for set 1, what's the difference? For set 1, they use 0.25 mole DN cube. Concentration, which one higher? Z2 higher. So that's why they collected more gases. That's why the reaction is higher. Same amount of time, the gas collected is higher. So this one is excess or the zinc carbonate. State 1 factor that affect the rate of reaction from diagram 7. Concentration. Or you can say concentration of hydrochloric acid also can, if you want to be complete. Then what is the reading needed to be recorded in both experiments to determine the rate of reaction in 3 minutes? What to read? Here, as I told you earlier, how much the gas is collected. How much is what? How to rate how much? cm cube. cm cube in what measurement? Volume. So volume, carbon dioxide collected. And by the way, this is the equation for C. Zinc carbonate react with hydrochloric acid become zinc 2 plus refined chloride ion. So it becomes zinc chloride, got salt. H and O, leftover is leftover. Leftover is H and O become H2O. Don't guess the equation normally. I mean, not to say guess, but you know the pattern is very good. Don't memorize mostly. H and O become H2O. C and O become carbonate, always got carbon dioxide. Then you times 2 here, HCl, because H and Cl got 2. Donkey calculate the average rate of reaction in set 1. So set 1 actually is, what's the volume? Rate of reaction is always volume per time or mass per time. But here normally they don't have mass. Normally they got mass, but sometimes they will come out. Mainly they will come out volume. So volume is set 1, 60 cm cube, 3 minutes. So 3 minutes, if you want to convert to second means times 1 minute equals to 60 seconds. So 3 times 60. Here. You can write 3 of 4 significant figure. cm cube per second. If you want to write cm cube per minute, it's not wrong. Yeah, but here it will be 20 cm cube minute -1. But normally I suggest is second lah. Unless they ask cm cube per minute. Unless. correlation theory explanation. So these two, what's the difference? What determine the difference? Concentration. So which one higher than which one reaction? Set 1 higher than set 2 actually higher than set 1. If you know. So rate of reaction in set 2 is higher than set 1. Concentration, why is it higher? You can say the concentration of hydrochloric acid used in set 2 is higher than set 1. Then you write number of hydrogen ion per unit volume. Concentration always like this one. Number of hydrogen ion per unit volume is higher than set 2. Now, actually, this one also related to ionic equation one. So the full equation is, I write down. Full equation is uh HCl react with ZnCO3 becomes ZnCl2 plus CO plus H2. Ionic equation is the one that involve chloride, it don't include. So chloride is not include. So what happened here is ionic equation is actually 2H plus react with zinc carbonate. And because carbonate becomes carbon dioxide, so it's also involved. So become zinc 2 plus. So the reactant is what? The reactant here is H hydrogen ion and zinc carbonate. So that's why I have to write frequency of collision between hydrogen ion and zinc carbonate is higher. To write frequency of collision, frequency of effective collision. I think it's safer because sometimes now when you don't know how to determine the marks you better write everything. Actually the marks is here the marks is for 3 marks this one is correct. This one 1 mark, 1 mark, 1 mark, and I think this one 1 mark. But if you don't not safe you just memorize everything write down, also no problem. Just in case let's say you forgot, then you write this one you might not get the marks sometimes. Depends, it depends. But safer because normally essay question, if you come out 5 marks you have to know how to write the whole everything. Okay, now okay. F what happened? F they ask the student wishes to increase the rate of reaction for set 1 by changing hydrochloric acid to sulfuric acid of the same concentration. So they ask, in your opinion, do you think he made the correct decision? Explain answer. So they want to increase the rate of reaction for set 1. So do you think he made a correct decision? The answer is yes. Yes, actually. They want to replace hydrochloric acid to this acid. even though they are same concentration, they actually it help a lot. Why? Remember, this is the SPM hidden question they always trick you on. Actually, he made a correlation. Why? Because sulfuric acid one time will produce how many hydrogen ion? 2 hydrogen ion. Yes, diprotic acid. You know this. Sometimes they come out this one. Instead of the amount of concentration 0.1, 0.2, 0.3, they also can come out what type of acid they use. What type of acid they use. For instance, this one complain. This one monoprotic acid. One time produce 1H plus. This one produce 2H plus. Of course, this one which one higher? One time. Of course, the concentration for this higher because one time already they already contain double. So yes, correct decision. Why you explain? Sulfuric acid is diprotic acid, yes. Although has same concentration of acid, even though they here also put 0.5, but the problem is this one diprotic acid doesn't matter. So this one time 2H plus compared to this one time H plus. This one faster lah because higher concentration. This one also can be the factor of higher or low concentration between monoprotic and diprotic acid. Di always be 2, mono always be 1, H plus. Concentration of hydrogen ion produced in sulfuric acid is doubled compared to hydrochloric acid. Double. Or you can say more also can lah. More than hydrochloric acid also can. So the relation is higher. Because they say concentration of hydrogen ion it produces double compared to this. Okay. Question 8. So question 8 is 4.5. Remember, the process of preparing soap, only one process one. You call saponification. You remember. So in this preparation of soap, palm oil is hydrolyzed to palmitic acid, and glycerol. Then this one actually is what? Palm oil is hydrolyzed. So because actually oil made up by what? Made up by glycerol and palmitic fatty acid, which is palmitic acid, then can be hydrolyzed back to this. So what happens is palmitic acid react with, remember how to form soap? Soap can be acid react with alkali. Can to form soap. In this case, palmitic acid react with sodium hydroxide to form soap. Similar to neutralization, quite similar when you form soap. The only problem is they need to add two more things. They need to add distilled water and sodium chloride to take out the precipitate of soap. So there's a thing how to process soap. You can look at the procedure as well. Starches and chemical they replace sodium hydroxide. Alkali can be used another alkali, which is normally you use starches, potassium hydroxide. These two can either sodium hydroxide or potassium hydroxide. These two alkali. It's a bit hard for you to see. So what happened? Okay, I show you a bit. I show you. So what happened is acid plus alkali. Which one acid? Actually, acid already given formula, which is this CH3CH2. No need to memorize one. No need to memorize. They will give one. So CH3, show you CH3 bracket CH2 14 COOH. React with what? Sodium hydroxide NaOH. What do you become? Now, still remember property of acid what happen? If it remember undergo neutralization, what do you take out? They take out water. So they take out water. Salt and water. So which one is salt? Salt actually here actually the soup. So they take out let's say take out the H here, OH here. So that you get, remember, just like ethanol acid react with this. So they will get CH3, CH. Actually, this one, the whole thing is negative charge. H plus is positive charge. So what do you get? You get CHCOH2, 14 COO, and A. And A. Because Na also 1 plus. CH3, CH2, 14 COO also 1 minus. So they try 1 to 1. Then, and water. Similar to neutralization. It is this one, the acid formula will be more complicated. But actually, palmitic acid formula don't have to memorize. They will give. They will give, then they only they ask you to write equation. If not, they won't. But you just have to remember what? You have to remember, undergo neutralization, you have to take out water, H2O. This key. They say H from here, OH from here. As a side product, H2O. Now, donkey, very, very simple question. And only 1 mark. So, you just use, they given you more, they give you molar mass. Very simple. Molar mass going to calculate 1 by 1 already. So you just do 78 times 0.05. Because number of mole equals to mass over molar mass. So mass equals to number of mole times molar mass. Sometimes they come out very easy question, sometimes come out tricky question. Depends lah. But you have to know the whole thing lah. Don't sometimes this easy question don't think too much. And it's just 1 mark only. Okay. E now E they come out they let them come out hard water one. If you still remember what's hard water. So hard water it contains of what ion? Ca2 plus and Mg2 plus. These 2 ions. Where these 2 ions when you use soap to wash, remember you have to there's a cleaning agent W, cleaning agent X one. So when you use soap you cannot wash off one. Hard water is just like your mineral water. Or your water in sea, or the water in I think swimming pool also. Then also the water in uh well. In well. So in well, like that. So when you use soap, you cannot wash off the stain. Any dirt you cannot wash off one. When you use detergent, yes. everything disappear. You have to know the difference. Why cannot use? Why can you why the cannot wash off? Yes, yes. Yes, just like window water, yes. You can just imagine you cannot use soap to take shower in uh in 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 sea. All the sea water cannot use, you can use sea water to, because it could form scum. The explanation is not bubble trap. Yeah. The explanation is scum. You have to remember. Now that one bubble trap, that one is uh they are more onto the washing clothes part one. This one is hard water. Hard water normally use soap form, they cannot wash off because they got scum form. Very simple explanation. Scum is a key. This one no scum. Scum means the insoluble salt, the precipitate one. They're blocking the soap from washing. They ask which cleaning agent is soap? Cleaning agent W. Now soap, this has this advantage one. They cannot, the normal water can wash, yes. But in hard water they cannot wash. Hard water or acidic water cannot wash off. Detergent, everything can. Soap is to wash your body one, normally. Detergent normally used to wash your clothes one. That's why detergent is more effective. Okay. F now F, you are given two separate beakers, P or Q, containing soap solution or detergent solution as respectively. So uh containing soap solution or detergent with the use of following materials. Describe briefly how you can distinguish. Distinguish is differentiate. What's the difference between soap and detergent? Now, remember, you just already did E ma. So E, what's the difference? We're using hard water. One you form scum, one you will not form scum. Now, so this is a material. Procedure, how do you differentiate? Calcium nitrate solution, boiling tubes, rubber stopper. Actually, calcium nitrate contain what ion? Calcium ion. As I mentioned, hard water contain what ion? Calcium ion and magnesium ion. So this one basically what they do is very simple. They just pour inside the beaker P, beaker Q. So which one got scum means soap. Which one no scum means detergent. Very simple. Now here is maybe a bit trick. This one you have to know hard water contain what ion. Then they given here what material. You just pour inside. Now how to write a procedure? Very simple. Pour 3 cm cube of uh uh bigger P and Q into different test tube that containing this solution. Or you don't want to write test tube, kind of write in boiling. Okay, right? 3 cm cube or this one, I think 2 cm cube, 2 cm cube, something like, but too little maybe. Maybe more, they can put it lah. Then close the test tube, we just with a stopper and just shake. Shake lah. Then which one got scum? That is soap. Very simple. You can write scum or write white precipitate. Also can. Just like this simple procedure. Actually, okay, boiling tube. So maybe you just, okay, maybe this one they use. Boiling tube. They give a boiling tube, boiling tube. Actually, boiling tube doesn't matter because maybe boiling tube a bit bigger size lah, but around the same. Or maybe boiling tube uh because here doesn't involve heating, so it doesn't really matter. But maybe boiling tube is bigger lah, bigger size. That it matters lah. Can I rubber stopper if I complete rubber stopper? Maybe we can just pour back into the beaker lah. Then you see which one. Or maybe don't have beaker lah. You know, maybe change back to because some of the answers is not really correct. So some of the word they use wrong, confusing. Okay. Da, da. Okay, maybe we okay. Question 9. So question 9 what happened? Form chapter this is form chapter 6, where now sometimes the question they come out strong acid or weak acid, but this one they come out same acid that dissolve in either in water normally lah, water or organic solvent. Example this case. So propanol and water. It can sometimes mostly these two lah. These two organic solvent, either you say methyl benzene or propanol. So water both will dissolve. The problem is will they ionize or not? Become ion or not? Yes, this one yes. All become ions. This one nothing become ion. We remain as neutral molecules. And they react with if they throw calcium carbonate inside, do they react or not? This one yes, they react. This one no. This one you can see you can bubble gas produced. Carbonate what gas will come out? Carbon dioxide. This one no. Because this one no ion. So compare the observation. Those who have maybe essay this question not enough space they if you test pad they use test pad. This is a comparison. Yeah, okay, I make it like this. Okay. So what happened? You can see comparison does not ionize in H8 in bigger P does not ionize, bigger Q ionize in water. They saw ionize mean what? Hydrogen ion are not produced. In front of it, hydrogen ions are produced. So when you throw calcium carbonate chip, what happened? No bubble gas. This one got colorless bubble gas from released. What gas is it? This is carbon dioxide. So carbon dioxide here is not released, here is released. That's why conclusion is HA does not show acidic properties. HA shows acidic properties. This one, the difference is between water and organic solvent. Remember, either acidic or alkaline, you need water to show its acidic or alkaline properties. Organic solvent is like, remember, it's like your petrol, your cooking oil, all that lah. Or other many example, as long as the liquid or solution is not water, that is called organic solvent. So you got 10 marks actually, comparison. Yeah. I mean, not 10 marks, 5 marks. So 1.1 mark lor, differences. Okay. Uh 9B. Now 9B, now they're talking about strong acid or weak acid. So what happen is, why is it strong acid, weak acid? Actually both are monoprotic acid. But if you notice, in this case, all become ion when both are in water. One in water. The problem is they have different acid now. They have HA acid, they have HB acid. So HA acid when they ionize in water, ionize completely one. This one ionize partially. Some maybe ionize in become hydrogen ion, some not, some remain as molecule. So monoprotic. Monoprotic it can't be H2SO4. They ask you to suggest what acid. So um uh this one is strong acid with 100% ionized. This one is weak acid with around weak acid around 1 point something, 1.3 or 1.5 percent ionized. So here the given value is, now you have to change the question value 0.01. You have to change 0.01 because I think the question is not accurately like right. So what happened is uh here they're given pH 4, which makes sense because weak acid. So weak acid normally the pH value is higher one. So they ask to predict this how much. Now they have to predict this uh uh you have to use the pH. Yeah, HB is ethanol acid. Yes. HA is not sulfuric acid because they say mono, it's not diprotic. They say HE and HB both are monoprotic acid. It can be either you can suggest hydrochloric acid or nitric acid. Yes, can both or yeah, you can suggest ethanol acid or and no ethanol acid for this one. This one it can be HCl or HNO3. I cannot be sulfuric acid because they always mention monoprotic acid, so you get wrong answer. So you can suggest the names, blah blah blah. Predict the X. So the X you can use this formula. pH equals to negative log H plus, where the solution have to change 0.01 is equals to 2. Now why here equals to 4? 4 because 1% ionized so you times 1%. Here the concentration is 1%. Basically the concentration here whereby for strong acid got ionized completely times 100%, 0.1 0.01. Here might be get you only 1% of this, so it's 0.0001. 0001. Yeah. So such a different. Explain the difference. You can say HA is hydrochloric acid or nitric acid, also can accepted. HB is ethanol acid. X is pH 2 based on the formula. I mean you can I mean I think pH 1 or pH 2 is accepted. Even though if the question didn't change. it should be accepted because maybe the question I think is not very accurate, I would say. Because based on the calculation strong acid, the given originally question is 0.1. If you put inside the log pH equals to negative log H, it should be you should get pH 1. But they say they predict, so basically maybe they say ionized 1%, ionized 100%. So this one maybe times only 1% of it ionized, this one 100%. So maybe divide by the difference is maybe around 2 lah. Then you can see what's the difference. HA is strong acid, HB is weak acid. HA ionized completely in water to produce higher concentration of H plus and A minus, while HB ionized partially in water to produce lower concentration of H plus and B minus. The A minus and B minus, you want to write also can, not a big deal. But you remember, right? Hydrogen ion is a must. Okay. B2 now B2 they ask 50 cm cube of acid HB in beaker S is added with 20 cm cube of water. State the name of the process involved and explain the change in the pH value. Now, 20% 20 cm cube of water. Suddenly the acid adds extra water. What happened? This one you might not remember, but this one is actually called, what's the process name? Adding water. It's a key. Basically, this one is dilution. You might not remember. This one is for, I think, related to 6.6. Form 4 chapter 6.6. Standard to prepare standard solution. We will add dilution. So, and explain the changes in pH value. So pH value, of course, you add water is pH value become increases. Why? Dilution. So when you add water, you get diluted. You get less concentrated. Process name is dilution. pH value with acid B increase because concentration of H plus decreases when water is added. Remember, the formula is M1V1 equals to M2V2 for dilution. Where you increase the volume of water, what happens? Molarity decreases. Means the concentration of hydrogen ion decreases. So that's why pH value increases. So that it's closer to neutral. Now, 9C, what happened? 9C, they want to prepare insoluble salt. So insoluble salt, remember how to prepare? if you want to prepare insoluble salt, you have to using two soluble salts. Remember, terbalik one, always terbalik. Then if you want to let's say you want to prepare soluble salt, then using SPM and insoluble salt. Terbalik one. Prepare soluble using insoluble, prepare insoluble using soluble. So this case they given you two soluble salt, which is copper 2 chloride and sodium carbonate. Sodium, so all sodium soluble one. And this one, copper 2 chloride, chloride, all soluble except PbBaCa. Copper 2 chloride is soluble. So what happened is, they asked what's the name of process. Do you remember what's the name of process? Name of the reaction, sorry. Name of the reaction of process. Reaction to prepare to prepare insoluble salt, equal this three words, which is double decomposition reaction. You have to notice, double decomposition reaction. How about the chemical equation? CuCl2 plus Na2CO3. What do you get? CuCl2 plus Na2CO3, you get CuCO3, which is the salt T, which is the insoluble. NaCl is soluble because Na. And you have to times 2 here, Na, because Na2Cl also 2 times 2 here. Basically, salt T talking about CuCO3. Then they ask to us calculate the mass of salt T form. Then they want to suggest one substance they can replace copper 2 chloride. So first of all, calculation first. Find number of mole. Here they given V, they given M. Same thing, mv over 1000. That's why you have to remember this formula because this formula is everywhere. Mole equals to over 1, mv 1000 equals to mv over 1000, mass over molar mass, volume over molar volume, especially mv over 1000. Always come on. So this two solution is the same. Just in case not same, you have to calculate both one. Because if you do ratio, very important. Let's say if not same, you have to choose a limiting factor. But no, mostly they give the same. So that's why the ratio 1 to 1 to 1 from equation. From here, you calculate 0.0125, same thing, produce the same amount of. The key is they want to find salt T. What is the mass of salt T? So salt T is copper 2 carbonate. Here is the key. You got number of mole, so they do what? You can find the mass. Because number of mole is mass over molar mass. So molar mass given 124. You just use 124 times this. Then you get answer. Then suggest one substance. One substance replace copper 2 chloride. So it can be, remember how to produce insoluble salt using soluble. So let's say I want to prepare CuCl3. You can use a shortcut where prepare this using in both soluble. So you can use fun. Prepare insoluble salt using soluble. So the first one is already got, which is sodium. You can use sodium, potassium, or ammonium carbonate, but here they use sodium carbonate. They want to change is copper 2 nitrate. I mean copper 2 chloride. It can be the trick part is here it can be nitrate or Cl, or SO4 also can be accepted. So here they salt T, they're using sodium, like sodium carbonate and copper 2 chloride, copper 2 chloride. So they want to use other salt. It can be copper 2 nitrate or copper 2 sulfate. Since these two also soluble. Not many cases can use SO4. Like for example, PbSO4 cannot, CaSO4 cannot, BSO4 cannot. If it is Ba or Pb or Cl, but this one is Cu. Cu can. It can be, normally I suggest, I recommend, this is safer, nitrate. Nitrate is safer. Normally I recommend this. Because nitrates for every salt is soluble. Sulfate doesn't necessarily. You might make mistake. So better not. Unless you're very confident. Okay. You can look at question 10. Question 10 is Form 5 Chapter 1. Now, this one, state the meaning of redox reaction. You still remember? Redox reaction what's the meaning? Oxidation and reduction reaction occur simultaneously. Like this means oxidation and reduction happen at the same time. So now determine whether the reaction is a redox reaction or not. Explain your answer in terms of change in oxidation number. Now, do you think this is a redox reaction? The answer is no. Why? Do you see any changes for oxidation number? No. Why? Na plus 1 is still plus 1. Cl minus 1 is still minus 1. Ag plus 1 is still plus 1. N plus 5 is still plus 5. O minus 2 is still minus 2. Now, so you can say, maybe some of you ask, how do you get plus 5? Because normally I know Na is Na plus Cl minus, so plus 1 and minus 1. Ag is plus 1, Ag plus 1. O is O2 minus, so minus 2. So maybe as well, I show you now. So Ag and O3. So Ag and O3, you see how to calculate the oxidation number. This is plus 1, this is minus 2. So you can use it, as X. So how many minus 2 here? 3. Because here got 3 ma. So you just use 3 times 2. 3 times negative 2. So everything plus become equals to 0. Why is equal to 0? Because outside of this AgNO3, do you have any special charge? No. So the whole thing is 0. Outside has no charge. If the outside, let's say, the whole thing suddenly got negative 3, then you equals to negative 3. Like this, you have to remember how to count. Equals 0, then here become negative 6, here plus 1. So x equals to plus 5. Because plus 1, negative 6, negative 5. Negative 5 move there, plus 5. Just in case, maybe some of you don't know. So explain. Now, this is the way. First of all, state the meaning. Redox reaction is a chemical reaction involving oxidation and reduction occurs simultaneously. It's a chemical reaction involving oxidation and reduction occurs simultaneously. You have to write this. The reaction is not a redox reaction. Because why? Because you can say oxidation number of each element before and after the reaction unchanged. Didn't change anything. Then you have to write in terms of, they say it's play in terms of oxidation number. You can say oxidation number of Ag before and after +1, Na before and after +1, Cl before and after -1, O before and after -2. I miss one negative. Wait. Then plus n before and after +5 respectively. If it is a redox reaction, then you can say one by one, then you say oxidation of Ag increases from blah 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 from +1 to +3, example. If it is redox reaction, if not just because I saw the answer scheme very lousy. Because why? They write everything. Oxidation number of Ag before after one sentence. For NA one sentence, we got 5 sentences. So very long. So I just cut short into one. And actually this one I think 4 marks only. Now B is just calculation. So calculation what? Calculation they just give so it's around the same calculation where mass over molar mass, mole equals mass over molar mass one. It's around the same one. So here they're given 800 kg of iron ore. So 800 kg, you calculate the mass of iron for this. Mass of this one, how much? So you got 800 kg in form. So you can calculate the number of mole first, then you do ratio 2 to 4. Then you just calculate mass equals to number of mole times mass. 800. So 800 kg. Kilo. So you need to times 1000. So you times 1000. Then Fe2, 2 times 56 plus 3 times 16. You get 5000 mole. This one maybe the number a bit big. So, but the calculation concept is the same. Calculate number of mole, then you do ratio 2 mole produce Fe 2 mole, this one produce 4 mole. So times 2, 5000 become 10,000. So mass of Fe is 56000 gram. Or if you want to write so many zero, you can write 56. You can change if you want to change. Normally I don't recommend. You can write 560 kg. Also can. It's the B1. Now, B2, they just ask determine the oxidation number of iron in compound Fe2O3 and state the ioctag nomenclature of the compound. So Fe2O3, very simple, how to count? They want to ask oxidation number of iron, -2. O3 is O, of course, it's O2 minus already. So -2. So how to calculate? Very simple. X is actually here is 2x. 2x plus here got 3 3 O so it's just 3 times -2 become equals to 0. Outside no charge, same thing, no plus, no charge is equals to 0. So you can just calculate it. After that, you can get X is 3. So oxidation number of F is +3. Sometimes people forget to write positive. You minus mark. Oxidation number, you have to write positive or negative. Don't just leave here. Are you take nomenclature mean what? They want you to name already. Basically the naming lah. What how the name? Iron 3. Now this is transition element. Transition element you need to write Roman number out. Iron 3 oxide. Okay. Uh, then you look at C. Now C two sets of experiments are carried out to study the effect of other metals on rusting of iron. For set 1, an iron nail is coiled with metal P. Set 2, iron nail is coiled with metal Q. Both coiled iron nail are dipped into hot jelly solution. Sometimes maybe they ask hot jelly. What is the purpose of putting hot jelly solution? It's just to make the color clearer so you can see. Containing potassium hexasulfate. Now, this is what for those who remember even the chemical test for Form 4 chapter 6 the cation test this one to test Fe, the presence of Fe2 plus potassium hexacyanoferrate. Very important. Whether they got Fe2 plus or not. This one normally will form dark blue precipitate normally. So and phenolphthalein. Phenolphthalein is a pink color one. Phenolphthalein to prove that there is no anything when this pink color when it's in alkali. So to prove that whether the iron rust or not. So you look at this. So what happened? Now this agar-agar solution, this jelly solution, all these what happened? Pink color shows iron did not rust. Very simple. If it is dark blue, it shows that Fe2 plus is present. So the iron nail rusted. Yes, I know, experiment. So what happened? Now, how to know which metal? Sometimes they ask you to suggest metal, like now, so I think they suggest metal. So the Fe, this is Fe. You need to same thing you have to remember the electrochemical series. So what happens is if it's below, then it will rust because below you cannot protect Fe. You cannot protect Fe, but on top can because on top is stronger. So you can protect Fe. Bottom cannot. So normally bottom either you can normally you choose PB or CU edging. Normally you choose CU edging. Where this P you can use Mg, L or Zn. Normally I use Mg or Zn. Normally these three don't recommend because these three very high reactivity and it will explode in the lab. So normally you don't recommend that. And the equation also you know, anode and cathode. Anode where the donate electron out from Fe become Fe2 plus. This shows that iron will rust. Iron rust. So the reactivity is iron rust. So cathode is where cathode, remember how iron how to rust? You got water and oxygen. I don't know this equation. Water and oxygen, they form OH minus. So OH minus what happen? Where Fe2 plus react with OH minus to form FeOH2. FeOH2. That's why FeOH2 shows that dark blue color is formed. Dark blue precipitate form. This one is not. This one zinc 2 plus react with, because this one zinc will become anode. Why? Because zinc is more reactive. So zinc react with OH minus here. We form ZnOH2. ZnOH, that's why alkaline. So alkaline, OH is alkaline base. So that's why you got pink color form. This one I show the phenolphthalein. So suggest metal P and Q. Explain why there's difference in the observation. include your half equation oxidation reaction and state the metal they are oxidized. Now, a metal oxidized is oxidation. For set 1 is zinc. For set 2 is iron. Then undergo oxidation to donate out electron. So you can set up. Metal P, it can be zinc, aluminum, or magnesium. Normally, I recommend either zinc or aluminum. Normally, I recommend these two. Then, aluminum also can. Then, tin, lead, copper, silver. Normally, I suggest copper or silver. Then you explain what's the difference in observation. Step 1, you say metal P is less electropositive than iron. Metal P is zinc. Sorry, I think this is Q. Wait, I think I read wrongly. Wait. Oh, correct. Step 1 actually is zinc 2 plus. Wait, terbalik. Dia nak terbalik. Zinc, Q, and P. Wait. Step 1 iron is not oxidized. Okay, wait. So, step 1 actually talking about P. Maybe I think I terbalik a bit. Wait. I think step 1 talking about P. Okay, I think I terbalik ni. Yang mana? I cancel a bit. So this one is metal Q. Metal P, right? Metal P is more electropositive than iron, sorry. Then I think the whole thing, wait. This one's supposed to be. I think I just read. Wait. Basically, this one should be. What is the volume? So now the volume. Step 2 is the one that more electropositive. Yeah, I just changed a bit. So now I do too much against the volume. Then the is okay. So I'm basically talking about metal P. I'm talking about metal Q. No, I'm correct, I think. Yeah. Set 1 is the one that do not rust. Rusting does not occur. Step 2 is the one that okay done. I think it's screenshot. I think basically metal P is more electropositive. More electropositive means they can form the positive ion more easily. Then Zn is Z, that's why zinc is iodized, pink color to show the OH minus ion. Rusting does not occur. This is a half equation, donate out electron. Zinc donate electron. Then metal P is less electropositive than iron. Because then that's why iron is more electropositive, that's why iodized. Dark blue color shows the presence of iron 2 ion. Then rusting occurs. That's why Fe become Fe2 plus. Done. Okay. Last question. So this one page question 11. This one from March 2. Now this one you still remember how to look at the reaction. So now glucose change to ethanol. You remember only now glucose become alcohol. Only one alcohol possible, which is ethanol. It cannot be methanol, it can be propanol, butanol, cannot. Glucose can only become ethanol. We undergo fermentation, where glucose will add yeast together. Undergo fermentation, become ethanol. So only one possible. So where this one is, and then this one undergo alcohol with this substance Z undergo esterification, become ester. The ester is ethyl butanoate. And this why butanoate? Because got 4C here. So this one 4C here also become butanoic acid, C3H7COOH. By the way, if they ask for this catalyst, you can add concentrated H2 as a form. Then oxidation means, remember oxidation is from how to become acid. Undergo oxidation. What we undergo oxidation become acid, which is alcohol. Here alcohol is different to this because this is 4C here. That's why here also got 4C. That's why you got C4H9OH. Butanol. Butanol become butanoic acid. Remember, if they ask for what is the thing added is acidify potassium manganate 7, or this also can, or this potassium acidify potassium dichromate 6. So general formula for alcohol. Remember, this is all the general formula, homologous series, functional group. You have to remember this. Important. In case they ask which one, you have to know. For alcohol is CnH2n plus 1 OH, where n equals to start from 1, 2, 3. Now, here the n also start from 1, 2, 3 for alkane alcohol. Only alkene start from 2, carboxylic acid start from 0. Just in case. Then alcohol X is ethanol, alcohol Y is butanol, substance side is butanoic acid. Now, I think you done, done. Okay. Never mind, every time you just screenshot. Or later I send you the answer back as well. Then I got explain. So using alcohol X and substance Z. So substance Z is acid. Alcohol plus acid become ester. So how do you prepare ester? Pineapple flavoring means ester. Then include chemical equation. So I just take a look answer. Very simple procedure only. Just put alcohol into boiling tube, put Z into boiling tube. Then you have to add you have to know. You have to add one more thing. We call concentrated sulfuric acid for esterification. You remember this, into the boiling tube. Then the mixture is shaken. Mixture is heated gently or slowly. Then pour the mixture onto water in a beaker. Why? You want to show that ester is insoluble in water. Then it proved that it's ester because alcohol and carboxylic acid is soluble. So you want to prove that ester is insoluble. Then this is the equation. You know, this is the equation. C2H5OH add with C3H7COH. Remember, the formula is C3H7COO right first. Then only with C2H5OH. You remember, you take out H and OH, become H2O side product. Then this one is ester. Then 11A3. Now 11A3 is functional group and draw the substitution formula of pineapple flavoring. Functional group for ester is carboxylate COO. So and draw a substitution formula. Substitution formula just according to the formula, chemical formula. Draw half carboxylic acid here, half alcohol here. Then calculate the mass of pineapple flavoring produced when 0.0 mole of alcohol X is used in the esterification reaction. So very simple. They already given molar mass equals to 116. So 0.03 mole also given. So very simple. 1 mole X produce 1 mole of water. 1 mole equation of 1 mole. This is 0.03 mole X equals produce 0.03 ester. So that's why after that you just calculate mass of ester equals to molar mass times number of mole. The molar mass already given 116. So 3.48 lah. I think you can just, I did I say the answer as well. Then for B, now for B, I explain what happened. So B, this one is oil A and oil B. Oil A contain mostly unsaturated fat. Oil B contain of half saturated fat and unsaturated fat. So this one only contains saturated fat. I mean this one is 11% unsaturated. This one is saturated fat. So saturated fat is a fat exists in solid. This one oil is contain more unsaturated fat. So this one is in oil form, is in liquid form. Now, sometimes this one they ask what happened is they ask the question. What you do? What the question asks? Wow, very long sentence. So what happened is what I saturated fat contain single covalent bond between carbon atoms, means along is alkane. So it can increase the level of cholesterol in bloodstream. Fat is more unhealthier compared to oil. So in terms of this more contain or more fat, more cholesterol, the chances of getting hypertension is even higher. So, but this unsaturated fat, but at the same time, unsaturated fat contain double carbon double bond. So double bond it will easily be oxidized. So it will cause what to form carcinogenic substances. Carcinogenic is cancer, the one that cause cancer one. So Fond Amina choose this oil to cook, to stir fry the mixed vegetables. Let's say they want to fry, they want to fry chicken or fry anything using this oil, and deep fry the chicken. See, deep fry the chicken. Does Fond Amina make the correct choices? Give the reason with a reference to effect of fats on health. Now, this question actually both answer accepted. You can choose. You can say she made correct or wrong decision on that. If she choose this, have good or bad things. If you choose this, have good or bad things. Why? Now you can say because if you say it's correct for oil B, because oil B contain of more unsaturated fat. Why? Because oil B is like olive oil, olive oil, all this kind of oil healthier. No, not olive oil for example, like palm oil as well. So this one this one is less. This one is more unsaturated fat. So unsaturated fat is more what you have less saturated fat. Saturated fat is a lot of cholesterol, a lot of fat. So if it is using oil B, then you can reduce the increase of cholesterol in blood. So for this what happened? What is the advantage? It's not so easy to get heart disease or obesity. Yeah, but if you choose oil A, if you say she made the wrong choices, incorrect choice, then you can say what happened? This is oil A contain of more saturated fat. Or you can say what is the advantage? You can say oil A is better for deep frying because unsaturated fat double bond. Then we have carcinogen substances, carcinogenic substances, so that you have lesser chances of getting cancer. Basically, what happens? If this one is more, then you cause cholesterol, a lot of cholesterol inside. Now this one you cause obesity. If it's this one, if it is double bond higher, what happen? Then the chance of get you have carcinogenic substances is higher. So that's why you cause cancer. Both have disadvantages and good advantage. Advantage at the same time. Okay, done. So I think today's class today is until here lah. So thank you for coming. You can leave lah. Bye bye.